The other day I was watching the news. Do you know that puzzles, like the jigsaw puzzles, little things with the you gotta fit the pieces together. They're the sales for them are way up. It's like one of the biggest selling items. So this was like a month ago, but still, it was you had your Clorox wipes and your whatever, your cleaning supplies. Masks weren't like a big thing yet, but yeah, jigsaw puzzles. So I thought, let's make some puzzles here. So here's your puzzle. What number would go in here that also goes in here? This has to be the same exact number. What could we plug in there? We could definitely plug in a 3 again, right? Because that would make each side 6 and 6. So 3 solves the puzzle, but that's not the only thing. We could also plug in 4 because then that would make that 7, and this would have to be a 4 as well, and that would be 7. You could also plug in, you ready for this? I'm going crazy right now. So this will be 1/2, and this will be 1/2. 3.5 and 3.5. It's the same on both sides. It doesn't have to be a whole number. It has to be just a real number. A real number is simply anything that can be classified as irrational or rational. So I could even put in like the square root of, you ready for this? Wear a seatbelt. Square root of 7 here and the square root of 7 here, because you have the same amount. 3 plus the square root of 7 equals 3 plus the square root of 7. So literally, I could put any solution in here. So just so we know, down here at the bottom, I'm going to write down 3 plus x. In 3 plus x. Why am I doing this? I want you to see this in equation terms. So this would be like your equal sign. X comes from the fact that I have no idea what this box is. 3 comes from the fact that I have every idea what the other box is. And the other side's the same story, 3 plus x. And so anytime you have a situation like this, there's all real numbers that will work for this. And the reason that we can always tell that, I'm going to put this in green right here. It's a very important number. But the coefficient for x is 1, meaning that you have 1 total x here. And you also have 1 total x here. If your coefficients are the same, and your constant terms, which is the 3 here and the 3 here, are the same, you have all real numbers that could work. This is like one of those things where everybody's happy. It's kind of like the kid at the playground that shares like his shovel in the sandbox, lets you go down the slide first, but still has a smile on his face when he does it. It's something for everybody. This right here is another example of, it could be anything. I could plug in 7 here, 7 here, 7 here, 7 here. In algebra terms, by the way, I could plug in 9, 4, whatever. In algebra terms, there are 2 x's, right? Because it wasn't born as 7. Let's get rid of this 7 here. It wasn't born as 7, so let's call it 2 x's. And on the other side was also 2 x's. Do you notice how the coefficients are the same again? It's a sign that it could be all real numbers. And we're also adding a constant value of nothing. And a constant value of nothing here. In other words, the last problem I had a constant value of 3. None of these boxes were known, so it's just 2 x's. So this is all real numbers again. If I had a problem that looked like this is a little bit of a different case. Again, you have to plug in the same number in each of these boxes. But if I tried to plug in 7 again, it wouldn't match the other side. So 7's not a solution. 7's too small. Each box has to be the same value. There's 3 boxes, so each box would be 10. And the way to show this algebraically, it would just be 3 x's equals 30. Hopefully that's starting to make sense. But what you notice is this side has a variable, this side doesn't. Anytime that's the situation, you're going to have exactly 1 solution on your hands. What about this one right here? Well, I start with 20 on the left. If I plug in, 1 over here and 1 over here, you're going to have 20 more on the left than you will on the right. What if I plugged in 11 instead? On the left, there'd be 31. On the right, there's 11. There's still 20 more on the left. I could change these numbers and manipulate them in a lot of different ways. Maybe if I make this a 14 and make this number right here a 14, the left side will still have 34 and the right side 14, which makes the left side 20 bigger. So this would be a case where you have 20 plus 1x, or x. I'm going to say 1x. And on the other side of the equation, you also have 1x. Well, the coefficients are the same again, but in this instance, the constant, which is 20 on the left, is different than the constant on this side, which you can't see, so therefore it's 0. anytime you have this where your coefficients are both the same, and in this case they're both 1, and your constants are both different, that's a situation where you have no solution. So just to review, no solution would be if you have the coefficients are the same, but the constants are different. One solution would be, well, you just have a single variable over here, I guess in this case 3 variables, and no variables over here. And then all real numbers would be if you have the same amount of variables on both sides and the same constants on both sides, like this one, or like this one right here, where we had the constant 3 on both sides, and we don't see it, but 1x and 1x over here. So just to look at some big picture equations here, I would combine like terms, call this 6x plus 7, and that's 6x plus 2. You have the same coefficients on both sides, so you could subtract these, and you'd eliminate the coefficients. You'd eliminate the variables. And you're left with 2 equals 7. That doesn't make any sense. So there's no solution. Over here, again, we can do what we have to do with the equation, manipulate it here. I'm going to distribute the 2 to make it 8x plus 6 on the right. And once again, your coefficients are both 8. The numbers that are multiplying the variables are called coefficients. So subtract the 8x, subtract the 8x here, and we're left with 3 equals 6. 3 equals 6 doesn't make any sense, so there's no solution. Right over here, again, combine the like terms. You get 5x plus 2 equals 5x plus 2. In this instance, this is a special case, you subtract 5x, again, the variables are going away. They're going to be no more. You're left with 2 equals 2. If you have that, that actually does make sense. So any number will work here. If your variables are eliminated and you're just left with constants that essentially equal each other, you'd say that this is all real numbers. And then finally right here, I can take 3x and I can take 3x, and I'm left with 6 equals 2x. So this would be an instance where you have one solution. 2 times 3, of course, equals 6. But again, you're left with variables all on one side, no variables on the other. So therefore, you had to have one solution. Last one I'm going to show you, and one thing I do want to tell you, my favorite vegetable growing up was cauliflower. Yeah, cauliflower. Is cauliflower, is it Cauliflower? Cauliflower? Maybe flower? I don't know. Cauliflower? That's a tough word to spell. Yeah, cauliflower is my favorite vegetable. But anyway, this one looks like it would be no solution because you're saying, well, what could I plug in these boxes to make it all true? But I want to show you. Do you notice how the coefficients are different? That means that there would be a solution here. So if you take 2x, you take 2x over here, you're actually left with, on the left side, 8 equals some number plus 8. Well, if you subtract by 8 on both sides, you're left with 0 on the left side and just an x on the right side. So it would make sense if you go back up here and you plug in 0, that's going to actually keep the scale balanced. So that would be a solution.